I work for Australian Glass Group. We're a glass processor. We've got plants in Sydney, Melbourne and Hobart. We specialise in double glazing. We love high performance glass that go in high performance windows, that go in energy efficient homes.
So how did you first get in the glass industry?
I've been in building industry my whole career, just not by design, by just fluke, but glass 14 years. Before that I looked through glass, now I look at glass. But I started with a global manufacturer of glass that opened my eyes to what actually glass can do, and that was Guardian Industries. Going from that template of double glazing to a colder climate, because I started in Melbourne with single glazed glass, and I thought, how cold is this? The first Airbnb for a month had the heating on 24/7 for the whole month we were there. I hate to see what the bill was for that. We're living in an artificial environment. Noise, we heard every single car that went by, and just general health, well-being and comfort was just terrible.
What risks show up when glass isn't tested for Australian mid-load?
Rings is an example of just an aesthetic, ugly look, but the worst thing that can happen, that glass could blow up. You got to cater for this. The worst thing is the frame will implode and the glass can break, and that's bloody dangerous.
What do you want builders to do differently after hearing this podcast?
Continue your education. It can be explained in an easy to understand way, and once you get it, and then you can make really informed decisions to make sure that what you use is compliant, fit for purpose, legal and safe.
Welcome back to the Build Better podcast, the show about lifting standards, backing Australian manufacturing and building properly the first time. Today I'm joined by Michael Ward from AGG, Australian Glass Group, and we're unpacking the NCC 2022, double glazing, myth versus performance, what real compliance actually looks like, acoustic performance, and why Australian-made glass matters more than people realise. This episode is about understanding what actually sits behind the glass we specify. Michael, welcome.
G'day Chris, thanks for having me. I think what you do with these podcasts are brilliant, so happy to be involved.
So before we get technical, I want people to understand who you are, Michael, if you don't mind just sharing a little bit about yourself.
Sure. So I work for Australian Glass Group. We're a glass processor. We've got plants in Sydney, Melbourne and Hobart. We specialise in double glazing. We love high performance glass that go in high performance windows, that go in energy efficient homes. We're all about that. We're very passionate about it. And I'm one of many long-serving, experienced, passionate people within AGG. So that's what we focus on.
So how did you first get in the glass industry?
14 years ago now. I just realised today that it goes fast. I knew nothing about glass before that. I've been in building industry my whole career, just not by design, by just fluke, but glass 14 years. Before that, I looked through glass. Now I look at glass. But I started with a global manufacturer of glass that opened my eyes to what actually glass can do, and that was Guardian Industries. Back then, 8 years ago, they were one of the biggest glass manufacturers in the world, but they really specialized again in high performance coated low E, so soft coats. And this was amazing. I was having colleagues from Europe and America that had 20, 30 years experience, PhDs as well, talk to me about glass and what it can do, and I was just hooked after that. I had no idea, so that got me really passionate about it. And then I saw what was going on in Australia. I was living in New Zealand back then, and New Zealand 19 years ago had codes that basically mandated double glazing as the norm of new builds.
And would you say that's because of the weather?
Their primary motive was actually health.
Okay.
Because of weather.
Yeah.
So their version of Medicare was seeing a huge high intake of breathing respiratory problems, especially with children, like asthma, and they linked that to cold, damp homes.
Okay.
So what can they do about it? Let's improve these windows, and that's where double glazing was their focus. Here in Australia, it's obviously carbon and greenhouse gas emissions and embodied carbon, and that's what's different here. But that had a template in New Zealand 19 years ago, and that's what I was used to and being brought up in. Then I moved to Australia because I saw what was happening. The codes here were talking about changes to improve windows, and I thought double glaze in Australia, going from a single glaze dominant country to double glaze, is a huge opportunity. And I knew that the education in double glazing wasn't as advanced as New Zealand. So I thought I could add some value and do some damage. So put my hand up to move to Australia and work for AGG. Luckily they said yes, and the rest is history. But what a difference. Going from that template of double glazing to a colder climate, because I started in Melbourne with single glazed glass. And I thought, how cold is this? The first Airbnb for a month had the heating on 24/7 for the whole month we were there. I hate to see what the was for that. We're living in an artificial environment. Don't know how clean those filters were because we were sick between my wife and kids probably 2 to 3 times each. We just shared that, being unhealthy. Noise, we heard every single car that went by, and just general health, well-being and comfort was just terrible.
Yeah.
And that's going from double glazed to single glazed in a colder environment. It was just phenomenal for me. Really stood out.
Makes a huge difference.
Big time.
So you mentioned soft-coated and hard-coated low-ease. Can you give us a little bit of an explanation between the two?
Hard coats have been around in Australia a lot more longer. They used to be made here. Hard coats are technical pyrolytics, and they're what we call online. So the way we make flat glass these days is a float line process. It's a big molten mixture of products that go on a molten bed of tin. And as it floats on this tin, it actually is nice and flat. So that's float glass / annealed. If you're making hard coats, while it's still red hot product, you spray on this chemical concoction and it becomes embedded in the glass. But you zoom into that now, it's no longer flat, it's peaks and troughs. And that's where light distraction can cause the haze that hard coats are well known for. But you can use it single glaze exposed. That comes with challenges as well. You're touching the coating, you're scratching the coating, your chemicals can affect it. That haze can get worse and performance can get hidden. But that's the traditional hard coats, easy to process as well. Soft coats, aka sputter coats, that's offline, and that's a physical process where atomic layers of metals go onto the glass. The main performance there is silver, Ag, and it's that silver that needs protecting. You can't use a soft coat single glaze with coating exposed. Must be in an IGU, must be in that air gap, protected and secure, but looks better, performs better. To me, it's a no-brainer.
Of course. And what does your role in AGG look like from day to day?
So I'm technically the National Marketing and Business Development Manager. Day to day, I head our service to our customers, which is day to day we've got this job. These are the frames we want to use. This is the energy report dictated minimum U value in total system SHGC. What's the answer for glass? And so we go through all the documents as part of our free service to our customers. We go through the hundreds of pages. We go through the energy. We go through if there's an acoustic or wind load need. We look at sizes for human impact and application. And we come up with a compliant option. And normally that's backed by published WERS data as well for total system U value SHGC. We can put that on a nice document we call a total system report, and that can be part of your tender and stand you out from the crowd when you're going for a project.
So this is part of a service that you guys offer if you purchase from AGG, is it?
Definitely. We consider, we go for partnerships. We don't like the customer that just shops around for the cheapest price. We look for quality, service, longevity, and that's part of the service when you deal with us for sure.
And part of your role, does it include any of the testing and going through the factory and understanding what's happening with the testing here as well?
We'd love to host people here. You've come through with your team. We love it on the fact that you get to see what's involved and you come out at the end of it with a newfound appreciation of, wow, to make a double glazed, soft coat, low E double glazed unit, it's not easy. There's a whole lot of steps and the finished product is quite phenomenal to achieve that. You get that appreciation of what's involved behind it when you come through a tour. So we love doing that. Not just customers, also builders, architects, we love that too.
So what does it actually mean to manufacture glass here in Australia?
Continues to be challenging, but you need to put your money where their mouth is. You need to have consistency. Therefore, you're relying on your suppliers of raw glass needs to be stable. Mm-hmm. They need to get their raw materials for the base product that's locked in and consistent and controlled. As soon as you start using a supplier that just 1 week buys their sand from here, the next week it's cheaper over there, you don't get that quality assurance, and that's where inclusions can be added in there, and that's where nickel sulfide issues for spontaneous combustion can happen. So we look for quality. So we deal with only reputable global brands. That has a cost. Somehow we get glass that's sticking out of a 20-foot container from halfway around the world to our warehouses here in Australia without being smashed. We get those units, we cut it to your size. It's very customized industry in Australia, which I think is good. It stops a lot of cookie cutter overseas imports. We customize those shapes. We make it all here. We've got on average about 7-day lead times at our 3 sites, Sydney, Melbourne, Hobart. Being made here that fast gives you quite a good service. And then the backup behind that, if there's a rework, if there's a wrong size, we speed that up as fast as we can. And then there's the technical and specification support behind that as well.
So how much investment has AGG made in their processes and systems? I mean, it's not every day that you can just click your finger and you've got a soft-coated line. For those that sort of don't understand, I do advise you to come down here and have a look at AGG's factory. It's amazing. Just how much investment goes into it?
It's ongoing. It doesn't stop. First, you need really good, reliable equipment. If a line's down, it screws your DIFOT and your service to your customers. But we're also looking for quality. On top of having good equipment, good people with experience and look after them well, you need to make sure that what you're making is consistent. So that's where aligning with AS standards is really good. So there's obviously standards for toughening for safety glass 2208, but also for the whole IGU process, AS 4666. 4666 needs someone looking at this full time. So each factory has a champion that will go through the daily shift processes that we've got to do. You're checking for quality of seal, of adherence of the seal. You're looking for argon gas, where argon gas is standard with all our IGUs. Got to make sure that we fill it up and it stays in there. And you're looking at overall performance. It's a whole lot of work. It keeps it front of mind and keeps us focused on it. But the result is it makes us make a better unit for better quality and longevity.
Talk to us about AS 4666, because it's a term that I know quite familiar. I'm quite familiar about, but I also know that not every glass supplier is AS 4666 compliant. Some may say they are, but whether they are or not all depends on the processes that they have in place and the end certification. So if you could talk to us just a little bit about that, that'd be... Sure
thing. So AS 4666 is the standard for manufacturing IGUs, insulated glass units that can be double glazed or triple glazed. It tells us the checks that we've got to do on a daily shift basis. So again, it's just focus on the quality in every aspect of the unit. A double glazed unit with a soft coat, it has 2 bits of glass. It has a spacer bar, there's a primary seal and then a secondary seal. We've got to look at everything from edge effect. Soft coat has to be edge deleted about 10 centimeters of the perimeter of every unit. Has to look good. There can't be any escape of gas when it's sealed. In situ, this is going in the lifespan of a building, so we don't want failures over time. Failures are quite often with a double glazed unit because as soon as the seal's broken, it will suck up atmosphere and moisture, and you'll see condensation on the inside of the air cap. So that's a telltale sign that the seal has failed and those units are no longer working like they should. AS 4666 just makes you accountable and focused on a daily basis on all these factors. Another point is every 2 years, you have to send physical units out to a independent accredited NATA lab that does longevity tests. So this is to check the seal and make sure there's no leakage of argon gas. They get units in a chamber that's incubated for weeks, and they measure the outside of this incubation box before of argon gas, which there should be none outside the units, and then they measure again after the incubation section. So this has to be done every 2 years to maintain your 4666. On top of that, there's annual independent audit by, we use Bureau Veritas, BV. They come on site each year at all 3 of our factories, and we go through the entire process, and they're very nitty-gritty on detail. They look at everything. Fortunately, we've passed every one that we've done, And then on top of that, beforehand, we do our official internal audit as well each year. So again, it's just focus, and just ingrains all the quality controls of making IGUs into us.
Yeah, so there's a lot of compliance that goes in making a unit, isn't there?
More than people realize, absolutely.
I mean, there's a lot of guys out there that are just making units in their warehouse, but they're not actually 4666 compliant.
Correct. One of the biggest things there is 4666 isn't specifically acknowledged in the NCC codes. AS 1288 is the use of glass in buildings, and AS 1288 talks about IGUs should be as per AS 4666. So it's referenced a second-hand way, and people use that as a get out of jail clause. Why it don't have to be 4666, but we're saying you do. And you'd want to buy a 4666 made unit because it gives you a whole lot of assurance of the longevity and quality of that unit.
And how much warranty does a AS 4666 certified unit give you?
We're industry norm, which is 7 years, but we have done projects that are 10 where it's required. Some projects do require that. We're happy to do that. We've been making IGUs, the origins of AGG go back over 40 years. And in our Melbourne site, one of the pioneers 30 plus years ago of making IGUs. So we've just stemmed from that. So we've got a very low rate over that 40-year period of failed units, to be honest. 9 times out of 10, when there is a failed unit, to be honest, it's an installation fault, not a manufacturing fault.
What happens in the installation process that can cause a fault for those that are unsure?
The main thing is about a failed unit. So you've got a primary seal with the spacer bar, and you've got a secondary seal. Either polysulfide or silicon are quite the norm materials. If both of those seals failed, again, you can see condensation inside. It's all about that common issue. That's what we're focusing on. That's what you've got to look for. So the common manufacturing fault the installation fault we call it, is when water's got in there. Water over time will eat through those primary and secondary seals, and that comes down to the design of the window itself. Has it got weep holes to let water that does naturally get in there through rain escape, and also the installation of the seals correct and are they put in the right position. So water is the biggest offender of failing IGUs, and we can't help it if water gets in there and eats away the seals, so that becomes an installation error, unfortunately.
Yeah. Or putting setting blocks in the wrong spot.
Oh, absolutely. Absolutely. You can put pressure if it's a big unit and you haven't used enough and it hasn't...
You're not bridging the gap over the filler.
Correct. And you haven't blocked the weep hole as well. You can actually pop up the IGU over just time, being how heavy they are.
Yeah. And in regards to the seals on the double glazed units, is there different types of seals that they use? Is it silicon, butane? What type
so PIB is the really common. When you've got a bendable spacer, and that can be aluminium or thermally broken warm edge, PIB is that primary seal. And that alone should be a decent seal if done properly. If you haven't got enough cover in it, especially in the corners, that's another point of failure. Then the secondary seal we do is standard polysulfide with residential, and silicon for the bigger commercial. Anything structural that's exposed to UV needs a structural silicon seal because polysulfide can be eaten away by UV as well. That's another failure. UV over time, if exposed, which it shouldn't in a 4-edge supported frame, can eat away polysulfide too.
So is it important that when you do purchase double glazed units and in your order you let them know if it is exposed?
Absolutely. It's crucial. We don't ask that question all the time. You can imagine how many orders we get a day. You give us an order, we'll make it. But if it's, for instance, skylights, all skylights should be silicon secondary seal, just even if it's 4-edge supported, just because of the position. Or if it's structurally glazed, like a curtain wall, must be silicon. You must put that on the order.
Yeah.
Good point.
From your perspective, what did the NCC 2022 actually change for glazing?
Where it impacted, very significant. So this was what brought me to Australia. When the government were now talking about NCC changes, it got me very excited. So the NCC formed in 2016 with this plan. Every 3 years, we'll do a new code with a step change of improvements to get to our Again, the motivation behind that, our carbon emissions. So the year 2030 and the year 2050, we've got some significant internal and external commitments. The NCC started with the first change in 2019 with commercial buildings, and we saw the demand in total system U value and SHGC of windows drop in U value and drop in solar heat gain coefficient. So higher performing windows, that's great. 2022 was the residential home new build turn. What we didn't anticipate was COVID. That delayed when that should have come out universally, which is fair enough. But then the ABCB government entity that came up with this plan spent a lot of time on it, a lot of money, I'm sure. And again, to get our carbon emission targets, they then gave the states and territories, all yours, do what you want with it. So unfortunately, all but one state delayed it at least. One particular state rejected the energy efficiency changes and still hasn't made an announcement when they'll take it on. Others eventually, when they took it on, then they put a 10-year stamp on it to say no more changes, it's too much, we've got lots going on. But New South Wales, where we are, they were the only one that took it on as is when it eventually came out after the COVID delays. So kudos to New South Wales. ACT, where our government is housed, federal, delayed it.
Right.
Victoria, our sustainable capital, delayed it. Tasmania, our coldest state, rejected it. I couldn't believe that. So New South Wales, let's look at them because they're the champions here. They took it on, and instantly we saw new builds now need, depending where you are, so parts of New South Wales are colder than other areas. The colder areas, which is defined West Sydney and South, so Parramatta West and down, double glaze is standard, is basically you can't avoid it anymore in a new build house. So it's a huge change, and we're talking about the energy efficiency changes, a Nat HERS star rating increase. It's all about how much energy these houses use. And when we become more energy efficient, we're reducing the total amount of energy these houses are allowed to use. What's the biggest energy use in a house? The ongoing heating and cooling of our homes. We need to live in a comfortable temperature all year round. When it's colder outside, artificial heating to bring it up to a comfortable level. When it's hot outside, artificial cooling to bring it down. But if we've got high performance windows, that's taken a lot of that job on itself. Therefore, you don't need as much cooling, you don't need as much heating. That is the true definition of energy efficiency. The same outcome, that comfortable inside temperature, by using less energy to do so. So we've found it huge, and we were waiting for this, and we actually realigned our New South Wales plant to be 100% double glaze focused. It used to be, the origins of New South Wales was Beverlite glass over 40 years. They were a single glaze processed provider. We flipped that on its head and went 100% double glaze. We completely changed the factory, completely changed the layout, new machines, new layout, and became a double glaze beast, and it's paid off. Because like I said, we've gone from probably about 9% of all homes in New South Wales that were double glaze a few years ago. We're close to 60% now of new homes requiring double glaze. So it's a phenomenal change to the industry, but we're one of the companies that have geared up for it to be able to supply it locally with local lead times and that service and support behind it as well.
And with the certification.
Absolutely. Really important. You've got to validate it. Absolutely. So AS2208 and 4666 is key. And then validating performance, and that's where WERS comes in, Window Energy Rating Scheme. That is taking certified simulations, auditing them, putting it on an independent website and showing you, well, this frame with this exact glass makeup gives you this total system U value and SHGC. WERS is good in multiple ways, being independent, but also any frame that's on WERS has been through a physical AS2047 test. That is a physical test of each frame with glass in it to look for water penetration, air infiltration, and serviceability and ultimate limit states of pressure to blow up to see what it can take. So you should feel rest assured any frame in WERS has gone through that, and any glass in WERS in those frames has gone through physical testing as well with the International Glazing Database. This is housed by the Lawrence Berkeley National Laboratory, a North American government entity. If you've got a new glass, per thickness, you need to send 20 samples at 300 by 300 to this entity. Their lab physically tests it and they prove that it's this visible light transmission, it's this visible light reflections in and out, it's this U value, it's this SHGC. Then they publish that on the IGDB with a specific ID number to that thickness. And so all the glass that's in WIS are also on this physical tested database. And then you get your total system data for proven validation of performance.
So talk to us a little bit about, you mentioned U value and SHGC. Can we just dive into both of those two so people can get a bit of an understanding what they actually mean?
Sure. They're important performance factors of windows, so much so that the building code dictates minimum performance in those two areas. They're both about heat transfer. SHGC, solar heat gain coefficient, is how much heat directly from the sun can come in. So a lower number means you're stopping more solar heat coming in. It does it in two ways. A, reflect it straight away, and also absorb some of that solar heat. Therefore, what transmits through is a lower number. Different glass and frames can have different reflection levels and different absorption levels. Therefore, your transmittance different. It's like a percentage. So 0.87 SHGC, you can think of that as 87% of the heat comes in from the sun. 0.27 SHGC, now only 27% comes in. So 73% is blocked via reflection and absorption. The lower the number, the more solar control you have. But you can't say one's better than the other. It all depends on the house design you're doing and the climate you're in. So warm climates, Queensland and Northern Territory, they want very low SHGCs. That's all they're really concerned about. They want to stop as much solar heat as possible. Colder climates, however, and I mean real cold, like ACT in Tasmania, they actually want to benefit from heat from a natural resource, the sun, coming in. So they actually have high SHGCs. U value is also talking about heat, but non-direct solar heat. That's body heat, heaters, heat pumps, fireplaces, light bulbs, and also indirect sun heat. So if you think of a 40-degree typical summer day in Australia, the materials are absorbing that heat. The footpaths, the concrete, the stones, the bricks, the roof, they're physically hot to touch. When the sun goes down, through physics, heat wants to go from where it's hot to where it's not. It re-radiates. And as it re-radiates, it changes from direct solar type heat to a longer frequency re-radiated heat. And that acts in line with the U value. If you've got really good insulation, low U value, that's going to stop that heat that's trying to come into your house at nighttime in summer. That's why good insulation works in hot climates. So two different types of heats, and they all impact how much heat either comes in or is retained. Therefore, how long is your cooler on, how long is your heater on. So that's why it's so significant that it's dictated in the NCC. Insulation is really double glaze with argon gas, with low E coating. Solar control is really the type of glass and frame that stops solar heat coming through. You can get tinted glass that does a good job by purely absorbing rather than reflecting. You can get highly reflective coatings that aren't low E that purely reflect rather than absorb. They both have challenges, or you can get low E's that do a nice balance of both, and therefore the result of solar heat coming through is the lowest. You need to have that range as well because of that fact. Hot climates really aren't really concerned about U value in the way we do building code, so it's all about low SHGC. Cold climates are all about low U value and high SHGC. Even here in New South Wales, you can have 3 building types in the same cul-de-sac: single-story detached, double-story townhouse, double-story detached architecturally designed home with lots of glazing. Those 3 buildings, even though they're in the same climate, same street, will have 3 completely different demands on their U value and SHGC of their windows. That's why you need to have a range, and you also need to prove it. So that's where we have, for instance, 4 different soft coats. We stock it 4, 5, 6, 8, and 10 mil thick as a complete range. And all of these have different performances, all low U value, which is good in any build, anywhere in the country, but that high to medium to low SHGC, whole spectrum covered to suit any job that's out there that we service.
Just talking about your different thicknesses in glass. So if you talk about a product that you guys sell, how much difference is it from a 4, 5, or 6 mil thick panel in performance?
and performance. If we look at, again, U value and SHGC performance, we tend to use 1 decimal point for U value, and it's Swedish rounding. You don't get any change in that 0.1 U value of different thickness of glass, whether it be coated or not. You do get a change in solar heat gain coefficient, but to be honest, it's minimum. It is like 0.01 of an SHGC change. It gets lower as you get thicker. Thicker glass does block more heat.
Yes.
But it's minimum, absolute minimum.
Price difference?
Price difference definitely goes up in thickness and also weight. So if you've got a 4 mil bit of glass, what's that, 8? That's 10 kilograms per square meter for 4 mil. If you go to 5 mil, what's that, 12.5? So you go from 2.5 kilograms per square meter heavier just by going 1 mil thicker.
Yes.
So that's dramatic. So if you don't need 5 mil or 6 mil and you can get away with 4 mil, there's benefits there, weight and cost, and no difference in performance.
So on an installation scheme of things as well, it's obviously a lot cheaper as well because the glass is not as heavy, so you don't need as many guys. But then talk about the spaces. Can you increase the spacer thickness to get you that? Say, for instance, if we were talking about a 24 mil double glazed unit, can we use a 4/16/4 to give you the 24 mil?
Absolutely. Some frames out there always want to maximize the same thickness. So no matter what thickness, you change the airspace to cater for that. We start at 6 mil thick spaces, the smallest. To be honest, a 4/6/4 double glazed unit doesn't give you that much insulation. We have the way we calculate total system U value is, because spaces affect the U value and acoustics, 12 mil is the optimum spacer. The way we calculate is we follow a North American procedure, and we call that the Australian Fenestration Rating Council, AFRC. They're the protocols of how we calculate it. 12 mil is your optimum. It's always going to give you the best, lowest U value whenever 12 mil is used. Much worse when you go less than that, and actually worse when you go higher than that, the way it's calculated. So 4/12/4 will give you a better U value than 4/16/4 in this country under deemed to satisfy AFRC methodology. Spaces go in evens, so 6, 8, 10, 12, 14, 16, 18, 20, 24, 2, 24. That's what we stock here. Then again, if you're doing a performance solution rather than deemed to satisfy, and that's where Passive House comes in. Passive House follows the European methodology under European standards. Excuse me, in a double glazed unit, 16 mil is the optimum spacer. So there's a big difference there. So if you're 4/12/4, you're actually getting a worse U value under Passive House European standards. But for our day-to-day here in Australia, always try and hit that 12, but it depends on the frame. So if you're using 4 mil, 4/12/4 is a 20 mil unit, you've got to be able to fit that. 5/12/5, 22, 6/12/6, 24. So wherever you can, 12 mil is optimum, but we can change to suit whatever frame it's going in.
And the fill, argon fill, does AGG use air?
Never, no. We moved years ago. So as standard, even a non-low E double glazed unit is argon filled as standard with us. No extra charge. The benefit is significant, and it's in the U value, the insulation factor. Total system U value will drop around 0.2 with a low E double glazed unit when you put argon versus air. That could be enough to actually get you compliant to this job or not. It's that valuable that we just added as a standard.
So, there's a lot of people out there getting quotes from overseas, window manufacturers overseas, and they come to us a lot of the time and say, but they're allowing for double glazing. And when we look at the double glazing that they've actually allowed for, it's only 5, 10, 5 clear.
Yeah.
I tend to go back to the client and let them know, look, it's no better performing than a 10/8 single glazed Comfort Plus or low E hard coated product because they're under that misconception.
Correct.
That they've got double glazing, so naturally it's meant to be better.
Yep.
What does AGG do here that combats that glass from overseas and being able to promote low E coated products?
Proving compliance is one of our biggest stances. So again, 4/666 made units, 2208 safety glass, locally made, 7-day lead times, locally supported. So we've got to validate what your job needs and that our solution complies to that. So we help customers go through everything on a project. We look at the plans, and these could be documents that are hundreds of pages, to be honest. What's the energy rating? As a new home build, it's a NatHERS report around the country, or BASIX in New South Wales. As a commercial, it's a Section J glazing facade calculation, but that dictates your minimum U-value SHGC. So first off, what glass in that exact frames that you're using will comply to the U-value SHGC. Then we cross-check that with sizes. We look at the plans, we look at the window and door schedule, and well, that glass is bigger for human impact AS1288. You can't use 4mm toughened glass in that. That has to be 5mm or 6mm or 8mm toughened glass double glaze. We cross-check that with acoustics. Is there advanced acoustic needs here? Are they building in an inner city next to a bus station or a train station? Acoustics is a big one, and wind loads. We love lots of glass, and lots of designers and owners want floor-to-ceiling massive panes of glass, which is fine. We love it. Yep. But you've got to consider obviously performance, size, thickness, but also wind loads. Especially if you're by the water. The glass has to be strong enough to resist positive and negative pressures of wind that are forcing onto that glass. So we do all of that. We can put all that into another report, what we call a glazing specification report, GSR, and that has all of those things covered, like a wind load report, like an acoustic report, and obviously the total system U-value SHGC.
It must be extremely valuable for your clients to be able to have access to that with you guys at the tender time.
We hope so, because they add that information with their tender. So hopefully that stands them out from their competition, especially overseas, which have they done that work? Are they 4666 certified? Can they prove it? Have they got their glass system in WIRS to validate total system performance? I would question all of those, and with us, you definitely get that support.
There's a lot of learning when it comes to double glazing. I mean, particularly around, for myself as well, in the last 6 to 12 months, we've had to learn quite a lot within my business, because we are now being pushed to use double glazing more and more frequently.
Right.
And you mentioned about wind loadings and tables and checking. It's not just AS1288 and human impact. You're now using the wind loading charts as well. All these documents are available from you guys if the client requests that, correct?
Definitely, absolutely.
Have you got a rule of thumb in regards to determining the thickness of the spacer between the glass?
Definitely. An easy rule of thumb. You take the span, or aka the smallest dimension out of the sizing, in millimeters divided by 150. That would tell you the sort of basic minimum thickness spacer you need. So that's another concern. If your frame can only fit a 464, 14mm double glazed unit, you're limited in how big you can go with that. Not only human impact, but also what we call structural integrity of the spacer. In situ and even delivery, we're putting that unit on a truck and a sucker's squished it to make it nice and tight. And in situ, you've got natural convex and concave from pressures in situ. That span divided by 150 will tell you minimum thickness.
And is that a standard, or where does that number come from?
It's an industry standard that everyone's been using as a rule of thumb.
Yeah.
Some cases we engineer it and say, oh, actually, a 10mm will work in this situation, and we can do that specific. We have structural engineer on board as our technical manager as well, so we can offer everything technical for applications.
So when system suppliers, window suppliers are coming up with systems, whether it be sliding doors, whether it be other windows, they should really be looking at that as a bare minimum to determine the thickness of the glass. If they're going to make these panels, at the moment, a lot of suppliers, they want these 3.5 metre high doors, 2.5 metre wide doors, and they design these systems, but I feel that they leave out this one important calculation to determine the thickness of the glass that they actually have.
Because they don't know. It's education, absolutely. And it's up to us, you and I, to educate the market, whether it be a window fabricator or the builder or the end user even.
Tell us about Newton rings.
Newton rings, okay. It's a visual, unpleasant aesthetic that you can get when two bits of glass in a double glaze are very close together. you do see that in these larger spans, especially sliding doors that move as well. It's a sign that the air gap's not big enough. So if you're getting Newton rings, which is this ugly rainbowy type metallic sort of aesthetic, it's an indication. If the glass is too close, then possibly you're not got the right space for the span and structural integrity as well.
And how often do you see that happen?
Rarely with us. To be honest, our customers play in the medium to upper residential range like yourself, and they've aligned themselves with die holders of frame systems that can fit nice, thick, like 24 mil sort of double glazed units. So our spec is one of them, and you don't have that risk.
How many times do you hear it from other from clients that have gone to other suppliers and they've had issues with Newton rings?
In the lower end mass build sort of market, absolutely. And again, it's probably a 6 mil spacer involved.
Yeah. And what does AGG do differently to help those clients ensure that they don't get that issue?
It's part of the service. Again, we try and install with our customers to engage us early on in the stage. The worst thing that could happen is they've tendered a job without our input. They've won the job, but they've used like 4 toughened, clear, double glazed unit pricing to win the job. Now they've got the job, they need to order the glass. That's when they send us all the details, and we go through it. Again, what's the U value? What's the SHGC? What's the frames you're using? Are there any wind loads? Are there any acoustic needs? What are the sizes? Then we come back to them and say, well, all of that, you need our most advanced performing soft coat low E in 8 mil thick with an acoustic lamb on the other side. And they say, oh, but we priced it on 4 clear toughen. So you've got to come to us early and we'll help you. It's free, part of the service with us, with our partner clients, and we'll get it right the first time. Really important.
How long does it take if, say, for instance, I was pricing a tender and I wanted to come to you? Bear in mind, I shouldn't be doing it at the last minute.
Yeah.
Should obviously be, as soon as I get the tender, I look at the documentation, send everything through. How long does it generally take to get some information back from AGG?
We actually try and push same-day service. We know how valuable having that information can be to you, to get your information in, to get the job, for us to get an order. So it's actually same day. If you come to us at 4:30 p.m., it'll be first thing next morning, but we always try same-day service.
Can imported IGUs claim compliance without Australian testing?
No, because we are Australia and we have certain requirements under Australian standards that are mandatory. When the NCC says must be as per, that's legal. That is law. They can't avoid it. So that means that unit is not compliant.
And how many times do we hear or see advertisements of compliance, but rarely do you see the certification?
Yeah, that's the scary thing. A good example is a recent industry trade show where it was very obvious a lot of the exhibitors were from overseas, and either they don't have that certification on display, or when they present it, it's not legit. That's not a correct certification. And it's happening more than people think. The question isn't being asked because, again, people don't know about this. Did you know it had to be 4666 compliant? Did you know you had to hit this U value in SHGC? Did you know you needed this minimum spacer? They don't know, so they don't ask and they don't check. And when they do, sometimes they get doctored information to prove it. We need more education, and we need policing. We need government entity to actually view a job, ideally at the design stage before it's actually being built and installed, so we can catch it then. So hopefully the government's working on that.
I think that's probably something that the industry's been crying out for some time, don't you?
It hurts local manufactured, absolutely. We can't compete with some of these prices from overseas, but it's not compliant. It's not safe. It's not fit for purpose.
And a lot of the builders wouldn't know that. They just see a certificate at the end of the day and, okay, they've signed for it, so it's compliant.
Correct.
But where does the checks go after that certificate's issued?
We need the front page of the newspaper to say, builder developer fined $100,000 because of non-compliant use, and that'll start a chain reaction, I think.
What risks show up when glass isn't tested for Australian wind loads? I mean, we just spoke about Newton rings, for instance. But what other risks are there if people aren't doing the proper checks like AGD does and goes through the charts and the tables to be able to recommend the adequate sizing of whether it be the spacer or the thickness of the glass, because that all changes in regards to wind loads.
Definitely. Well, rings is an example of just an aesthetic, ugly look, but the worst thing that can happen, that glass could blow up.
Yeah.
The frame could be pushed in if there's significant wind load, and also there's negative pressure stronger, and this is when we start talking about corner window. A corner window isn't a window right on the corner, it's within 1200 mils of a corner. That wind comes back and there's a backflow of pressure that is the negative pressure. You got to cater for this. The worst thing is the frame will implode and the glass can break, and that's bloody dangerous.
Yeah, it is. And it makes me question why people aren't asking these certain questions like you guys are. I know when we submit a quote, and it might border on the line of whether it's compliant or not with thickness and the spacer, we'll always get the questions asked by you guys. What's the N rating? Whereabouts is it located? Is it exposed? Is it non-exposed? Is it on the corner? Is it not?
Yeah.
And that information that we then provide, you can then go away and determine the best adequate glass and spacer for us.
Absolutely safe and fit for purpose.
So let's talk about acoustics. This is something that we briefly touched on before we started the podcast. There's a misconception in the market and also for clients that double glazing is always better for acoustic.
That's not necessarily correct. No.
So tell me from your opinion, Mike, what is better for acoustic purposes? Not energy, just acoustic.
Gotcha. Just acoustic. So, it depends on the noise offender. This is a key point about acoustics. We use a common average weighted decibel blocking performance value called RW. It's average weighted across a whole frequency of different noises. Low frequency is low bass noise, high frequency or high screech noise. RW is sort of like in the middle for common sort of noises. So it's a great comparison for that reason. But if you've got a specific acoustic need, the first question is, what's the noise offender? If it's low bass noise, mass thickness is actually the best to block that. And that could be a 10 mil bit of glass, could do a great job there. If it's really high frequency, that's where acoustic lam comes in. So laminated glass that has a specific acoustic interlayer. And if it's a mix of the middle, that's where a combination of the both. So a double glaze with an acoustic lam, but now you're thicker, more expensive. Different spaces in a double glaze helps. So with acoustics, the bigger the better in terms of the spacer. And then if you jump to the ultimate secondary glazing, that's where like 100 mil is the optimum for acoustics. But going back to double glaze, a bigger spacer is better. But if it's just general noise where RW is sufficient, a 10.38 lam, standard lam, can actually outperform a 412-4 double glaze units in terms of acoustics alone.
So it's always something that comes across my desk anyway, is people ask, we want double glazing, and the first thing we say is, why do you want double glazing? If it's energy, that's one thing, but if it's acoustics, it's another. And am I wrong to say that you can't have the best of both, because you're not going to be able to achieve the same acoustics with a double glazing in the sense of two panels with the separation instead of a double glaze unit itself? So I guess what I'm trying to say here is, if you want the acoustic performance of your window to be the ultimate, sometimes you're not going to be able to perform the best energy efficiency wise. So with a double glaze unit, you can fit 10.5 VLAM hush or hush, audio shield acoustic lamp, whatever the product may be in that unit. But then you might not be able to fit that actual double glaze unit into the frame itself.
Correct.
Or the door itself.
Correct.
Besides that, it's going to weigh a lot more in weight.
And cost.
Where you could use a 12.5 or 12.76 acoustic laminated product.
Yep.
And that's going to perform, the glass alone is an RW40. And when you put it in a frame, tend to lose approximately 2 decimal points or
Correct.
2 RW values.
Yep.
So we're at RW38.
Yep.
Compare that to the sizable double glazed unit you need to achieve to get the same acoustic. It's not going to be there for you.
Correct. And again, if it's just average noise and RW is relevant, you can get the same RW with a single glaze standard lamp versus a common double glaze. But it is best of both worlds when you do have a thick double glaze. So a frame that can fit that. Our spec do have wide pocket frames that can. That's when you do get best of both worlds. A thick air gap, a thick glass monolithic with a low E maybe for non-acoustics, and then a thick acoustic lamp on the other. But like you said, it has to fit a big unit in a big frame. It's more heavier, it's more cost effective. If you're just looking for common noise offenders, that's where RW is relevant. 10.38 standard lamp could do that if that was the sole demand of their needs.
There's another rating here as well. Can you tell us what the STC rating means?
STC, to be honest, it's not commonly used these days. So STC was the RW back in the day. They're both average weighted measurements. And what you'll find is STC equals RW anyway. It's very rare that they're different numbers anyway. RW is just a more up-to-date average weighted value that we use. So they're both just averages across a hertz frequency range.
How do you describe what the RW rating is to a client so that they can understand the value of increasing the glass performance?
Gotcha. So RW is how much common noise offender blockage in decibels. So the higher the number, the better. So an RW of 38 is saying it's going to block 38 decibels of common noise offenders from coming in. So we have industry norms of what each living space in a house should be to live a comfortable living room versus bedroom where you want to sleep. It's more advanced versus a laundry that doesn't really matter as much. So you know what it should be minimum inside. You know what the common outside noise offending decibel is. So the difference between that minus that is the blocking you need to do is minimum. So the higher, the better the noise blocking. But again, what's the noise offender? What's the room you're in? This is a good solution to block. So it's this RW inside.
Just want to leave with a couple of other points just in regards to the work behind what AGG are currently doing in the market. Can you explain anything new that you guys are working on? Any products that you're seeing that are coming to the market soon? Or that people would be quite interested in? I know there's a couple of new products that are coming in from you guys that you're replacing a couple of older products. If you want to talk about that, that'd be fantastic.
Sure thing. One of the stems that we try and push is education. So we've done advertising. We've done industry events. We've really started to like focusing on specifiers. So the architects and especially energy raters, sometimes builders and developers. So there's events out there that you have a little trade show stand for 2 hours and you just an elevator pitch on glass and glazing. We have these heat boxes that you know pretty well, where heat lamps and you can interchange double glaze or glass units. How much heat goes through a standard double glaze you can touch and feel. How much heat goes through a really advanced low E coated double glaze, minimum. So you can actually feel the performance going there. So that's what we educate architects in. Also, the two key minimum dictated performances, U-value and SHGC, that's where you start. We reference them to WIRS because there's a lot of frames and a lot of glass types in there. Education on that is important. Education with our customers on the total picture. So here's your job. Look at first your energy report, your minimum U-value SHGC you need to hit. Then look at sizes for human impact, how thick the glass needs to be. Then look if there's wind loads, then look if there's acoustics, and overlay all of them to come up with a good solution. Education in that is important for people to look at all those areas. Trade shows, Sydney Build, we're exhibiting this year. It's coming up in a few months. This is industry professionals from architects to developers to window fabricators, no public, so it's really B2B. And again, it's our opportunity to educate really well. Educate not only those areas you need to focus on, but also how we can help. So we've got a huge product range that can cater to all of those different parameters. and also the backup support behind it. So our technical spec reports and our glazing spec reports, and also new products. We've realized that the market has changed over the 8 years, and it's increased the demand of high performing glass, specifically significantly. So as the demand grows, supply will grow and catch up. So we've invested in machinery to make better, faster units. We've invested in people, and we've invested in logistics to deliver, whether it be a site delivery or into a factory. And this has allowed us to also align with a new entry-level product called Instaglass Lowy Eco, economical living that with ecological performance. So an introduction to energy efficiency with a good-looking, clear soft-coat Lowy at a more economical price. We found this was needed in the market for certain customer and clientele that have this demand now, and the supply wasn't there. So we're stepping up to be able to provide to that as well.
How much of a difference has it made for the Australian market not to be able to purchase glass from Oceania?
Terrible. Oceania closing down, no more glass is made in Australia. The cost of manufacturing in Australia wasn't supported by government, and look what's happened. We are now forced 100% to import all of our raw glass. So again, these are coming in containers for us, 20-foot containers, glass sticking out of an A-frame with a tarpaulin on the top. We have 2 extra factories on top of our 3 sites that demand all of these containers, and then we feed our plants directly with our big float line trucks. But that's eventually going to add costs. I mean, it should always be more expensive to import glass than to buy it locally. Oceania was fantastic, well-known brands, really good quality clear float. We would have 1 or 2 week lead times, and they would deliver it in their float liners in 20 minutes. We've got it. Now we have to order 3 months in advance at minimum. We have to bring that container in. 2 people have to devan it. Then we need to put it on a truck to come to us. We need to stock it. We engaged a second warehouse because of this. There's more costs involved with that. The more costs and hassle we get, unfortunately, it does affect our sale price sometimes. So it's a challenge. And the smaller players that aren't built for receiving a full container of glass and safely overhead craning it, where are they going to get their glass from? It's a huge impact.
Yeah. I mean, nothing's made here at all anymore. It's all being processed.
Correct.
So how does that affect you with the suppliers overseas as well? Is there a certain amount of suppliers you can purchase from overseas?
Yeah, we keep that tight.
Yeah.
Fortunately, unfortunately, Oceania never made soft coat Lowies in this country, so we were always importing that. We align ourselves with reputable global players only. We deal with certain countries, and some countries we don't deal with. We really want stability, quality, and reliability from our suppliers, so we only deal with the top end. We've just grown that relationship further and expanded our capabilities. So we've already been bringing in glass and devanning it, sending it to our factories. Now we've added a second warehouse. We just do more of it.
Talk about capabilities. What's the biggest size of glass that you guys can manufacture?
I gotcha. If it was single glaze toughened, for instance, we can do 2.8 meters by 5 meters. Mm-hmm. If it was an IGU, 2.7 by 5 meters. That's a massive unit.
Huge panel, yeah. And where does that glass come from?
So our Tasmanian plant had the most room, so that's got the biggest equipment in the group for AGG. So made in Tas, but we've got really effective inter-branch logistics.
Yes.
Where it can be made into Tas, sent the next week to our Melbourne site, sent the next day to our Sydney site, and we can deliver to a customer like you in Sydney, made in Tas all the way up. You wouldn't notice a difference.
So we've spoken about double glazing, but let's touch on a little bit about the triple glazing.
Yep.
Is there a big performance difference between double and triple?
Only when you add 2 Lowy coatings into a triple. Going from a double glaze with a soft coat Lowy to a triple glaze with 1 Lowy, minimum difference, to be honest. It's only with a triple glaze now you can put a second soft coat. That's when you get phenomenally lower U value, and that's significant.
But are the systems in Australia set up for triple glazing?
To be honest, not aluminium. but there's UPVC and timber that is aligning with it. And this is where that performance solution passive house, 8 years ago, we'd get 1 or 2 inquiries a year about passive house. Now it's 1 or 2 a week. It has really grown from nothing to a dominant sort of request from us. This is where those frames can cater to triple glaze. And I'm talking like 50 mil sort of triple glaze units.
Yeah, wow. And where are these passive homes being built?
A lot in colder climates like Victoria and Tas, but it'll surprise you how much in Sydney is actually being built as well. One thing to be aware of there is coming from a German-orientated colder climate body, they're all about low U value and high equivalent of solar heat gain coefficient. They want as much heat from the sun to come in these negative 30 degree sort of climates. We've got to make sure we account for the Australian market here. Low UV values, absolutely, but we actually want a lower solar heat gain coefficient for these triples in warmer climates. So again, having that range of soft coats, we can change the outer coating to actually give us the U value and the SHGC without compromising look or visible light.
So I just want to ask a couple of quick questions. What keeps you optimistic about the Australian industry?
Well, the government has started to act with codes and dictating minimum performance. They still claim to have a trajectory. To be honest, I think the trajectory is dead. There's no way we're going to hit our targets by 2030 by all these delays. But it's still there in the background. And what it has done is change the mindsets of the public, the builders, the industry, that high performance is stepping up in Australia. So that's a good momentum, good move. Hopefully it continues and we'll keep going there. What else? The understanding about compliance is getting louder because of people like you, people like us. We're educating, and we have noticed, and I've gladly seen energy raters and building agents actually bounce back a project saying, well, then no, that's not compliant. I've started to see that. That is a great sign.
That is a good sign.
Yeah.
What do you want builders to do differently after hearing this podcast?
Continue your education. It can be explained in an easy to understand way. And once you get it. And then you can make really informed decisions to make sure that what you use is compliant, fit for purpose, legal, and safe.
And then if you could set one non-negotiable standard for glazing in Australia, what would it be?
Double glaze the whole country.
I agree with you there. Look, thank you very much for coming on the podcast today, Michael. I really appreciate your insights and sharing your knowledge with everybody that's listening.
Brilliant. Thank you, Chris.
Thank you.